Hello, my dear students. I am B S Pandey, your physics lecturer. My dear students, in standard 12th, we have completed till the chapter electromagnetic induction. We are moving in alternating current, and today we will be in lecture number 74. My dear students, in this chapter, that is the alternating current, we have studied about the relation between the RMS value and peak value of alternating current and voltage. Okay, today we'll proceed, and before starting the today's lecture, my dear students, I will discuss over the another form of RMS value of AC voltage and current. Then we will apply the alternating current to the resistor, and one by one we will apply to the different circuit. Okay, students, so let's start today's lecture. It is lecture number 74. Lecture number 74. We are in chapter number 7 of NCERT, and alternating current we are studying, that is the AC. Okay, student, we have studied the alternating current, which has the two values. It is the peak value and RMS value. Okay, and one more thing we have studied, it is the average value. Okay, how to represent the average value? First, let me talk that one. If we want to represent the average value, if it is we are going to find out the average value of instantaneous current. If the instantaneous current is given, then how you will find out the average value? Then the formula was, for any function which is changing with the time, it is it dt for the full cycle, or for any particular cycle you can say, and it is dt. This was our formula for the average. Okay, we have studied then after the RMS value. If I0 was the peak value, then IRMS we have represented as I0 by √2. We have calculated, and ERMS, it is equals to E0 by √2. One thing I have discussed in lecture, the value we get as a current or the voltage in our household circuit, that is the ERMS. Remember, not the peak value. We don't get the maximum value as I0 or the maximum voltage as 220 volt. The maximum value is more than 220 volt. Okay, but that is the RMS value we used to read over the meter. It is established in our household circuit. Okay, now on the basis of, we can solve few more questions, but before that let me explain you, my dear students, how could you write the RMS value in terms of this average value. Okay, so that you will be able to solve few more important questions. Okay, look at here. RMS value, this is called the root mean square value. Alright, if IRMS, I will write, it could be, looks like I1 square, I2 square till IN square. I hope you understand. This is the total current divided by N. Okay, now it becomes average of square current. I hope you understand. This is the average of square current. Don't write this one. Okay, but try to understand this particular thing. It is the average of, that is the mean of the square of the current. Alright, that is the mean of the square. And if we'll apply here the root, then it will be considered as the root mean square current, and this is IRMS. Okay, my dear students, and this is the IRMS. Could we write this one as, you can see, could we write, my dear student, this one as, this is the I square. Alright, this is the I square, and this bracket represent the average value. Yes, average value. But if we put here a root, whether this one is the IRMS, the answer is yes, this is the IRMS. How? This is the average of square root, so this is the IRMS. And if this is IRMS, try to understand why I am representing this one. I'll give you a question. If this one is IRMS, then we can write this one as I square, it is as I t dt over dt, over dt. What is this one? This one is the average. Okay, you can see this is the average. If I'll put here I square dt over dt, then what will become? It will be the I square average. Am I right? Yes, this will be the I square average. Now if I'll put a root over here, then it becomes IRMS. So this is another form of IRMS. This one is the very, very important. Now it will be more clear if we'll solve few questions. Okay, my dear student. So look at here carefully. Okay, one question, a very simple question, my dear students, not very tough. I am going to discuss here. Suppose this is 4 ampere and this one is minus 4 ampere. Alright. And so on. This is the time. This is for half cycle till 3t/2 and so on. Alright, this is the 4 ampere, this is the minus 4 ampere. Now one by one, my dear students, I am going to ask you question. Could you tell me, my dear student, the average value of current in full cycle? Could you tell me the average value of current in full cycle? Now the answer is average value. Look at here, in half cycle it is plus 4 ampere. In next half cycle it becomes minus 4. So the average will be how much? It is 0. Now could you tell me average value in half cycle? Could you tell me the average value in half cycle? So the answer will be, in half cycle the average value, it will be, since it is the constant, so the average value not going to be changed in half cycle, it remains same, and it is 4 ampere. Okay, now the next question I'm going to ask you. Okay, could you find the IRMS? Now this is the question. Could you find the IRMS? You have to calculate the RMS value. How you will calculate the IRMS? Could you find? If you can find, kindly pause the video and try to solve this question. This is not very difficult, my dear students. As I have given you the concept, you can use that concept to solve this question. You have to find the IRMS value. Okay, try to solve. Okay, let me solve. My dear student, I square dt by dt will give you the square of average. All right, that is the square of average. If you will make here its root, it becomes IRMS. For full cycle, whatever may be the value you want for full cycle or half cycle, you can give here the limits. For full cycle, it becomes 0 to t. Okay, it becomes 0 to t. You can put. Now, how will solve? So bear in your mind this graph. It is, what was the value of I, and this is the I which is peak value. Remember, the current was not fluctuating, it was a constant and its value was 4 ampere. So the 4 square, it is dt divided by dt will be integrated and it gives 2 root. Okay, 4 is 16, it will be out, and dt will be the t by t, that is the 4 ampere. Okay, my dear student, so this will be the answer. The RMS value will be 4 ampere. Now if you can solve, I am giving you one more question. Okay, we will do more question on the basis of this one later on. I'll give you after the phasor diagram. Okay, my dear students, let me start the concept of phasor diagram by studying the AC across resistor only. Okay, we'll apply the AC across resistor circuit. Okay, resistor circuit. What we are having, remember my dear students, this is a very important topic for your examination as well. You will be asked here the one very important question. Okay, one very important question. It is, represent the output AC current through a resistor if AC supplied. Okay, AC voltage supplied. Draw the phasor diagram, explain its phase difference with the voltage, and represent the sinusoidal graph. These all things you will be asked to derive. Okay, you may be asked from this question, derive mathematical expression for the average power for AC circuit AC circuit for resistor. Okay, so this type of question you will have to face. So look at here carefully, my dear students. We are having a resistor applied through an AC supply. E t equals to E naught sine omega t. Here the resistance R. What we have supplied here? So supplied voltage Et equals to E naught sine omega t. If you remember, my dear student, in standard 11th you have studied about the phase. Could you find the phase of this Et? Yes, here the phase of Et is omega t. I hope you understand. I hope you remember. This is the phase. So it is the phase. Here the phase is omega t. We will discuss about the phase later on, but try to understand here how to find the output current. Okay. For at any instant, my dear student, we can study here the instantaneous current as well. If it is moving, remember the AC current has no specific direction, but I am representing here for the instantaneous. For any instant, the current will go in this direction and this direction. Okay, so this is the instantaneous one. Applying KVL, Kirchhoff's voltage law, what we can write, my dear students? We can write the total voltage, it is E0 sine omega t, and the voltage dropped over the resistor. There is no other device in this circuit, so the voltage only drop over the resistor. And we can write here in this complete mesh loop, that is in complete loop, E0 sine omega t minus ITR is equals to 0, or E0 sine omega t is equals to ITR, or IT can be written as E0 by R sine omega t. Alright, and this is nothing but I0 sine omega t. My dear students, this is our output current. This is the output current. Now, if you will find the phase of, this is the second equation we can write. Now, could you write the phase of current here? Phase of current, that is IT. So you will find again omega t. And what will be the phase difference? Phase difference in IT and ET, could you tell me? It is omega t minus omega t and 0. What does it mean? It means current and voltage both are moving with same phase. That's why the phase difference is 0. No one is leading or lagging with each other. This is the meaning of phase and phase difference that we have studied in standard level. The leading and lagging phenomena. Here both are having the same phase omega t. It means there is no phase difference. Voltage and current are moving in same phase. Okay, what is the benefit of moving both the current and voltage in same phase? We will try to understand. Okay, my dear student. Now, my dear students, if we are having the value of voltage as well as the current, then we can obtain for few more quantities of this circuit. Okay, and what are that quantity that you have to study? Look at here. The next one will be the instantaneous power. Could you find the instantaneous power? Yes. Instantaneous power, that is PT, and this PT can be written as ET into IT, which is E0 sine omega t into I0 sine omega t. Why? Because E0 and ET and IT we are having here. We can write it E0 I0 sine square omega t. This is the equation number 3. This is the 2. No? This is the equation number 2. This is the instantaneous power. Okay. Now we can find out the average power. Average power in full cycle, average power in half cycle, etc. We can calculate. Okay. So now we are going to find here the average power. Okay. Yes. Let me rub this one. I hope you have noted down. We know that to find the average power, what we have to do, so we have to integrate the instantaneous power with the specific limit. Okay, we have to integrate this one, this equation, average power. You can give the heading, my dear student, as average power. Average power. Okay, and this average power can be written as Pt dt over dt for full cycle. You can write this way. Now the Pt, it is E naught I naught sine square omega t dt by dt from 0 to t. I hope you understand. This will be out E naught I naught and divided by this t. So we are having sine square omega t dt only. Could you integrate this one? This is the square function. No, you can't. So we need to convert it, and I taught you how to convert it for simplicity. So you have to convert 1 minus cos 2 omega t by 2 dt. I hope you remember. Here 2 will be out, E naught I naught by 2t integration of dt from 0 to t minus integration of cos 2 omega t dt from 0 to t. Am I right? Now do the integration. It is E naught I naught by 2t. This is t minus, here minus plus sine 2 omega t by 2 omega from 0 to t. For full cycle, remember the value of sine must be 0. You know that. For full cycle it will be 0. Okay. So directly, my dear students, we can write, if this is 0, then it is E naught I naught by 2t into t, and it becomes E naught I naught by 2. What is this? This is the average power. Now you can see here, my dear student, the average power, it is E naught I naught. You can write this equation in terms of RMS value of current and voltage as well. How? So this average power, it is E naught by root 2 into I naught by root 2, that is E RMS into I RMS. So average power, my dear students, remember, it is I RMS into E RMS. For resistive circuit, for the circuit in which there is resistor only, then power can be written as, average power can be written as I RMS into E RMS. Okay, my dear student. Okay, now we will try to plot sinusoidal graph for this quantity, and then in next lecture we will start in very detail about the phasor diagram. Okay, my dear students, will not be very hard. we are going to plot here sinusoidal graph. Okay, what we have right now, till now, what we have calculated? We have calculated instantaneous voltage as it is E naught sin omega t. We are having instantaneous current IT as I naught sin omega t. We are having power as PT E naught I naught sin square omega t. Okay, so we are going to represent this quantity over the graph. We have also studied the phase difference between the current and voltage over here. It was 0. Now we are going to plot the sinusoidal graph. Look at it carefully. It is the 0 value. Which one having the greater amplitude? ET, IT or PT? The answer is PT having the greater amplitude. Okay, PT is the product of E naught I naught. But in comparison to ET and IT, which one having the greater amplitude? Because to represent over the graph, we need to find the amplitude as well. So we have studied in last lecture. If you will go to the previous lecture, my previous lecture, you will find that the ET will have the greater amplitude. And remember, in this chapter, everywhere we'll study the voltage will have the greater amplitude. Okay, why? So let me recall. The E is I times R. So this I multiplied with R actually increases the amplitude of E. That's why I'm telling you. Now here, if this is E, this would be I, and if this is P. Alright. Now this is the reference of I and this is the reference of E. For the same value, this is the minus E minus E. This is the maximum values, E naught, I naught. Okay, now the time periods. Here I am giving you the scale. In exam, take your time and draw the graph carefully, because if you will draw this diagram carefully, it will look like very beautiful, and the second thing, you will be able to explain clearly. Now the graph of I, so it is I naught sin omega t. The peak value is I naught and it will fluctuate with the sign. It means at 0 its maximum value, that is its IT will be at 0, IT will be 0. So we have to start from here, and as we go at the 90 degree, it will goes to the maximum, it is I naught. So this graph will goes like this one. I hope you understand. Now graph for ET. So you can see this is the same as the IT. So its graph will be like this one. At the same angle, at the same time, it will give you the maximum value as given by current. Okay, sorry, it's exceeding. Like this way. Okay, so this is the graph of IT, this is the graph of ET. Now let me discuss about the graph of power. You can see, my dear students, if this is the magnitude, amplitude E naught I naught, and both are the positive, so for any value we know that the sign varies from -1 to +1. Am I right? This varies from -1 to +1, but the square function always makes this as positive. So the value of ET will not goes down. For each cycle it remains above the reference axis, but its phase will be the same, omega t. This one having the same phase. So I'm sorry, this is the mistake. Okay, it should not goes for the negative scale. Again it will goes positive. Okay, and from here it again goes positive. So this is the graph of instantaneous power. Remember, I'm not representing here the graph of any average value, RMS value. I'm representing here the instantaneous value. But you can find out the peak values for each quantities over here. This is the peak values. This is E naught I naught. This is E naught, and this is I naught. Okay, my dear students. So this is the sinusoidal representation of current and voltage under AC supply. Today we have supplied the alternating current in resistor, that is the resistive circuit. From next day we will study what will happen if we'll supply the AC current in inductor, in capacitor individually. And then we have to study what will happen if we'll supply that same AC current in combined L, C and R circuit. But next class, that is the next lecture, we will start from the phasor diagram. Okay, that is the phasor representation. Okay, my dear students, so this is all about today's lecture number 74. Thank you very much.